One of the things that we can do with our angles and radians is to determine the length of an arc on a circle. So let's recap real quick what on earth an arc is from geometry. So if we have a circle, and here's the center of our circle, this piece of the circumference of the circle is an arc. Okay. Now, if we have an angle in radians, we can use this formula to help us figure out the arc length. S equals R times theta. So this variable S represents the arc length. So label that on my diagram here. R is the radius of your circle. And this symbol theta represents the angle measure. The angle has to be in radians. That angle has to be in radians. So that's one of the really easy things to forget with this formula is that we need our angle to be in radians. Okay, so again, this formula works pretty easily for us to figure out the length of that arc. Now with that formula, we are going to do an application problem. And I'm going to call this example 1A. Or I should call this example 3A, I guess. Example 3A. A satellite travels the circumference of Earth in a day. The height of the satellite is 36,000 kilometers. The radius of Earth is 6,400 kilometers. About how far does the satellite travel in 8 hours? Okay, so first of all, I have this situation talking about the satellite. Before I do anything else, I'm going to draw a picture for us to kind of help figure out what arc length we are looking for in our diagram. So let's start off with Earth. Okay. Here's the Earth, and it says that the radius of Earth is 6,400 kilometers. Now the satellite is traveling the circumference of Earth. So we're traveling the circumference. Our satellite is orbiting something kind of like this. And we know that that satellite's height is 36,000 kilometers. So from Earth all the way out to where that satellite is 36,000. Now this isn't totally to scale, but you get the idea here. We want to figure out if this satellite goes all the way around Earth in a day, how far does this satellite go in 8 hours? Okay. So I want to figure out a chunk of this outside here. Now, if my satellite is traveling for 8 hours and there's 24 hours in a day, that tells me that our satellite is going to go a third of the way around our circle. So our satellite is traveling from about here to here. That looks like about a third of our circle. And as you can see, this is the length of an arc. So to find that length, we have to use that arc length formula here. S equals R times theta. And again, S is our arc length. That's what we're looking for. R is the radius of our circle. Well, look at the radius of what we have here. The radius of our circle isn't just this 36,000, because that would just be the distance from the satellite to Earth. The radius is this total distance here, the 6,400 plus the 36,000. So the radius is really 42,400 kilometers. Now we have to figure out what theta is. Well, again, that satellite is going to travel a third of our circle. And our angle has to be in radians. So if our satellite is traveling a third of the circle, the whole circle is 2 pi radians. We have to have a third of that. A third of 2 pi. Well, that 2 pi is the same thing as 2 pi over 1. Multiply the tops together, we get 2 pi over 3 radians. Okay, so our angle is 2 pi over 3 radians. Our radius is 42,400. We plug that into our formula. S equals 42,400 times 2 pi over 3. And if we type that in our calculator, that'll tell us how far our satellite has traveled in the 8 hours. 42,400 times 2 pi over 3. So our satellite travels approximately 88,802.35 kilometers in that 8-hour span. That's pretty far.